Problem number 24 in the textbook. It's right here. So here's what they did is, and I'm going to paraphrase it because I don't want to read the whole thing. But it's basically a table of values. What they did is in the city of St. Louis, they took the temperature, the average temperature for each month of the year, and then they want us to write an equation that models this data. So in January, the first month of the year, the temperature, the average temperature was 34. In February, it was 30. March was 39, and so on and so forth. So there's a couple of things. First thing that we want to do is let's enter the data into a list on our calculator. So let me clear out my stuff here. And I've already done this problem. So what you would do is you would go to Stat, and you would hit Edit. And so what I've done is I've pretty much just listed the data, you know, the month in the column 1 and the temperature in column 2. And then if I go to Stat Plot, and you get there by hitting second Y equals, make sure it's turned on. It's turned on, yes, bless you. And then I want to zoom in. And I think it's option number 9. By the way, you know that if I can hit enter while it's highlighted, or I can just hit the number 9.
Yeah.
And so anyways, that looks like a sine wave. So, but the textbook, and I'll show you how we can verify that information in a second, but the textbook is asking us to write this as a function of sine. So they want us to write like amplitude of sine times the quantity b of, or times t minus h plus k. And so A is the amplitude, B has an effect on the period, and H is kind of like the shrinking or stretching, and K is the vertical shift. All right. So when we look at this data, if I hit trace, all right, so this is like when x equals 1, y equals 34, next point 2 and 30, and then 3 and 39, and yes, I know I mispronounced 30, but I'm talking and clicking and doing all this stuff. 4 is 44, and so on and so forth. All right, so now they want me to find A, B, H, and K using my brain. So, the amplitude, conceptually, is what? Well, conceptually, what it is it's the distance from the lowest point to the highest point. More importantly, though, it's halfway between, right? Because when we think of the original sine wave, and I'm going to draw a sine wave over here so we can kind of in our minds think about what the sine wave is and then how we fit that original sine wave to data. So, my sine wave starts at the origin, right?
Yes.
And it goes like this, and it goes like this, right? And so it has an amplitude of 1 because it goes from 1 to negative 1. And then the x-axis goes right through the middle of it, okay?
Yeah.
So what I would like to do is figure out the amplitude. So how does the amplitude, if this has an amplitude of 1, how do I apply that information? Well, my lowest point here is negative 1. My highest point here is positive 1. What's the distance between the two of them? 2. So how do I figure out the amplitude?
30 minus 80, which is 50, and the answer.
Okay, so somebody said take 80. So if we want to find A, he said you take the 80 minus the 30, which is 50. So the amplitude is 50?
No, it's 20.
Oh, so it's got to be all this divided by 2, which is equal to 25. All right, we're going to check this in a second, see if we're right. Okay? So the amplitude is 25. Now, let's be careful, be quiet. Now the period represents when the cycle starts over.
2 pi.
And it is usually represented by 2 pi. So that's a good place to start. So usually the period is equal to oops, forgot the O. 2 pi, but it can be transformed by the b term. Now remember that a fraction can also be a ratio. So if 2 pi is the distance for sine to repeat its cycle, and in this graph, the x-axis represents the time, how long or how much time goes by before we reset the cycle? Huh?
A year.
A year, which is how many months?
12.
12 months. So 2 pi should be equal to 12 months, right? Because this is the 9th month, this is the 10th month, the 11th month, the 12th month, and this is, if this is truly a sinusogenous function, then it should start over at 12 months. Can I do something with this numerically?
It's just pi over 6.
Pi over 6. Man, you guys are smart kids. I don't care what your parents say. So let's assume that b equals pi over 6, okay?
Okay.
All right, so now we've got to do the stretchy thing. All right, so let's look at this. The original sign starts right here at the origin.
Well, that's not true, but
Where do you think we start here? If you were to like draw a line through the middle, am I there?
No,
Am I there?
no,
No.
no.
Let's come back to this h concept. I think if we solve k, that would be better. So let's solve for k. So k is the vertical shift. Now, we said that the amplitude is 25.
So then we start at what?
Our lowest y value is 30. Our highest y value is 80. We need to put a line right through the middle of that. So y equals a number. What number goes right through the middle of 30?
80.
And how'd you guys come up with that?
80.
No,
Is that
30.
8 plus 30 divided by 2.
No, 30 is like, yeah, or 30 plus like that. Maybe.
That works too.
All right, so let's see. You guys were kind of rambling, but that's okay. You were close. All right.
No, we got it.
No, you can do 80 plus 30 divided by 2. That's so much easier.
So that goes right through the middle. Now, h is where the cycle begins, based on what the original sine function looks like. In other words, we had to, we're going to slide this graph over so many spaces. So now let's look at the graph again. Where would this begin, if you had to guess?
Around 12.
About 5, right? About 5. Do you guys agree with that?
Sure.
So if I took this point and shifted it over 5 units, it would look like sine, wouldn't it? My original sine? So what I'm doing is I'm starting with the original sine that kind of does one of these things, but I'm shifting it over 5 units. So h equals 5. All right, we're doing good so far. So if that's the case, then my equation should be, if I know what I'm doing,
25.
it should be y, oops, let's write it over here. Y is equal to a, which is 25. I know, I'm going to move it in a second.
Pi over 6.
Sine pi over 6
What is t?
times t minus 5 plus 55, right? That should be my function, right?
T is x.
Yeah, t would be x, right?
It's not a parametric function.
Well, it doesn't matter. You could label it as x if you want to.
Okay.
Okay? Actually, let me rewrite that. That looks horrible. So, it should be y is equal to 25 sine of pi over 6, and this could be t or x or any variable, minus 5 plus 55. Okay? That's what we should have. Now, how could I double check that?
Graph it.
Well, I've already graphed it. How do I double check it?
Line of best fit.
Line of best fit. So if I hit second, stat, oh no, just hit stat, I'm sorry. Then go over to calc, and I'm going to scroll down till I get to,
Line of best fit.
sine regression.
Same thing.
Sit right back.
Now, by default, it'll automatically choose L1, L2, but I want to save this.
Bars, Y bars function.
Yep, so I'm going to hit vars.
Function.
Now, I already have stuff graphed in function number 1, so I'm going to choose function number 2.
Graph.
Watch this. Well, bam, with the bacon sizzle.
I said that the other night,
Graph
I was
what?
doing homework.
So RA was 25 by just guessing. The calculator fits the data to the points a little closer. So the calculator spit out 23. So we're pretty close. For the B term, it was pi over 6. For their B term, it was 0.5, but well, not that much though. Look at this. If I do pi divided by 6 as a decimal, it's 0.52. Theirs was 0.53.
Well, what about C, the C term?
C's
Or
pretty
R,
wrong.
C's off a little bit.
H.
Okay, C's off a little bit. We said -5. They said -2.
We're wrong.
0.5.
We said that the vertical shift was 55. They said 55.02. Right? So, not bad. Not bad at all.
Hit the graph.
But this is the answer in the book. You're not supposed to. Oh, so let's see what it looks like. So now if I hit graph,